So there's the fork and join parallelism concept that you need to know. You can start basically when you're programming, you can create children in the parent thread. So threads can create children and wait for their completion basically. So to wait for the completion, you call thread join. But once you create a thread, okay, you cannot share data. You cannot, for example, create a variable in one of the threads and expect the other threads to see it. So data is only shared before fork or after join. So if you have if you want to share variables, if you want to share data between the threads, you have to define this data, these variables that you're going to share before you actually do the threading, because then all threads will see it. It will be like a global. If you try creating if you try creating a variable in a thread and expect the other threads to see it, this is very unlikely, probably will not happen, very hard to do, almost impossible. It depends on the I'm basically trying to tell you that in most systems this will not be acceptable, okay? And it's very bad programming practice also to basically have the variables or the shared data created inside the threads, and this is for multiple reasons, and we'll go through them. So you want to share data, you create the data type, you create the variables before you share before you do the threading. Also, you basically can do this sharing of the information after join. So after all the threads are done, you now have all the outputs of the threads. If you basically implement them correctly, then all the inputs from the threads should be somewhere stored safe. Okay. I gave some examples of how of the threading applications. One very famous example is web servers, Apache web server, where you basically fork a new thread for every new connection. So if you have a web server, if you're connecting to Google or if you're connecting to Facebook or something, you typically have the case that when you basically establish a connection, when you establish a network connection, then the Apache server in the system, like in the remote system, will create a new thread for every new connection. Okay. There is like merge sorting, there are parallel memory copy, there are many examples of applications that use threading. Sequential is not concurrent because, well, concurrent is parallel, sequential is in series. In parallel programming, if the first thread runs before the second thread, okay, we saw an example where the results can actually be different from if the second thread runs before the third thread. It basically depends on the interleaving of threads access to shared objects. Okay, so if we saw an example last time when we were basically adding 10 million to a variable, and you saw that if you run that code multiple times, you will get different summation towards the end, because basically when we basically went through why this interleaving is problematic. So program execution can be non-deterministic, problem that we saw last time, due to scheduling. This has been basically defined as Jim Gray's Heisenbugs. If you know the Heisenberg model of the atom, where basically you cannot know where the electron is. So Jim Gray, who was a very famous computer scientist, he was lost at sea and he died. Well, most people think he drowned basically in the sea. He was a very, very famous computer scientist who actually had collaborations with UMass. So he has a couple of papers with Prashant Shenoy, for example. So Jim Gray was a Microsoft engineer, distinguished engineer, very well known, and he basically talked about parallel computers, where parallel programs where you have non-deterministic outputs, and called these issues as Heisenbugs. They are very, very hard to debug because, well, you see the code, you think everything is just fine, but well, it's basically the scheduler or the compiler reordering your instructions. Okay. Race conditions is when the behavior of a program depends on the interleaving of operations of different threads. It's basically the formal definition of what we were talking about. And and it's called race conditions because who executes first wins. So it's basically when two threads are racing towards accessing the same data object, and whoever gets access first wins. Basically enforces his point of view on the on what this variable should be. So they do not try to cooperate, which they should be when they are accessing the data objects. They rather race. Let's give an example similar to the previous example. What can be the output of this program if x is equal to 0 initially? Thread 0, x is equal to x plus 1. Thread 1, x is equal to x plus 2.